The numerical is a 3-hinge parabolic arch of 20 meter span and 4 meter central rise carries a point load of 150 kilonewton at 4 meter from horizontally from the left hand hinge. Calculate the normal thrust and shear force at a section under the point load. Now diagram for the given data is we have drawn two support A and B, which is at a distance 20 meter as the span is given 20 meter, and rise, your central rise is 4 meter. It is also given that a 150 kN point load is acting at 4 meter from left support. So we have taken a point load 150 kN at point D, which is horizontally at a distance 4 meter. Hinge, this is your support A and this support B. And we know that for hinge support there are two reactions, horizontal and vertical. So we will take, this is your VA and this one is HA. Similarly this support B, so B having vertical reaction VB and horizontal reaction HB. Now we can solve this support reaction by considering the condition of equilibrium. So step number 1, to find support reaction. Now take moment clockwise positive, taking moment about point A is equal to 0. Now see here, this HA and VA is acting at a point A from which we are taking moment. Now this is your vertical force whose line of action is this one and perpendicular distance is 4 meter. And this force rotate clockwise, so 150 into 4 is your positive as the moment of this force. And there is no other moment rather than this VB. So it will be take anti-clockwise moment as this force rotate this distance anti-clockwise, so minus VB into 20 is equal to 0. So from this you will get VB is equal to 150 into 4 divided by 20, this 0 get cancelled, this 4 and 2 get cancelled, 15 to the 30 kilonewton. So like this we got the support reaction at this particular point VB. Now we'll apply the another condition of equilibrium, summation of Fy is equal to 0 and upward is positive. So see here in this particular, this is VA and VB upward and this 150 is downward. So upward positive, downward negative. I am taking VA and this plus VB minus this downward 150 is equal to 0. Hence I am getting VA is equal to 150 minus VB, which is equal to 150 minus the value of VB is our 30. So minus 30 is equal to, hence VA is equal to 120 kilonewton upward. So like this we got support reaction VA and VB. Now we'll apply the third condition of equilibrium, summation of Fx is equal to 0. And here this is rightward HA and this is leftward HB. So rightward is positive HA and this leftward minus HB is equal to 0, and we will get hence HA is equal to HB, and let us consider it as a H. This is our equation 1. So in this particular, when we consider equilibrium whole arch, we will apply three conditions: summation of Fy is equal to, summation of M is equal to 0, summation of Fy is equal to 0, and summation of Fx is equal to 0. Out of 4 unknown, we got 2 unknown, and we got one relation HA is equal to HB, which is equal to H. Now to find this horizontal thrust, what we will consider? We can consider either, we have this hinge, we can consider either this equilibrium of left half portion or we can consider equilibrium of right half portion. We have freedom to consider either left or right side of that particular arch. Now step number 2, to find horizontal thrust. That is H. And we'll consider FBD of right half part. Right side portion, that is CB. And if I consider the FBD of this CB, so this is my C at which there is a HC and VC. This is the internal hinge. Hinge has two reactions, horizontal and vertical, and this is already our external hinge support VB and HB. VB is known to us. VB we already calculated, that is 30 kilonewton, and HB is equal to, we can say, H. Now this is your C and this is your B. So distance CB, here this is total 20 meter. So central half is 10 meter and this rise is here 4 meter. So we can easily calculate this horizontal reaction by taking moment about hinge. Now we'll taking moment about hinge at crown. So moment about C is equal to 0. As it's a hinge, the moment about the hinge is always 0. So I'm taking moment about this C. So summation of moment about C is equal to 0. So these two forces which are acting at this point C, the moment of these two forces is 0. This produces a anti-clockwise movement. So minus VB into perpendicular distance is 10, and this horizontal force produces a clockwise movement. So that is plus H into 4 is equal to 0. Hence 4H is equal to the value of VB. The value of VB is 30 into 10. So hence H is equal to 300 divided by 4. You will get 75 kilonewton. So like this we can find out the support reaction. So here we want to calculate this normal thrust and shear force at a section under the point load. So the section under the point load which is at a distance 4 meter. So we have taken this section AD in an elaborate way over here. This is your A and this point is D. This distance is X and this one is your Y at point D. Now we know that along this perpendicular to this plane, this is your normal thrust and tangential to this plane is your radial shear, and we have to calculate these two forces. To calculate this normal thrust and radial shear, we have to calculate horizontal at D and vertical at D. But in this numerical, at the point D, where we have to calculate vertical, already this 150 kilonewton is at. So VD is the vertical force acting at point D, and in addition to that, this 150 kilonewton force is also acted at the same point. Now to calculate this HD and VD, what we have to apply? We just have to apply the condition of equilibrium. That is summation of Fy is equal to 0 and summation of Fx is equal to 0. To find summation of Fy is equal to 0, this is your upward 120 upward, this is minus 150 and this one is minus Vd is equal to 0. So hence we will get Vd is equal to minus 30 kilonewton. We get value of Vd is equal to minus 30 kilonewton. Now we can apply the another condition of equilibrium to find out this horizontal force at D. Summation of Fx is equal to 0. Now summation of fx is equal to 0. This is my 75 rightward plus minus hd is equal to 0. There is no another force in horizontal direction. Only this 75 and hd. And from this you will get a value of hd is equal to 75 kilonewton. So hd means your h in the formula and vd is nothing but v in your formula of radial and transverse shear. Now to calculate this normal thrust, we have the formula nt is equal to standard formula v. See, we can resolve these forces like this one, and this is we can resolve like this one. Theta is with respect to horizontal, so here hd cos theta, and theta is with respect to vertical, so this is vd sin theta. So now here normal force in this direction, so your both forces are in the same direction, so we can write vd sin theta plus hd cos theta. So it's very simple, both are positive because your normal thrust in the leftward direction and your both force in the leftward direction. So your formula will be very simple, and we can put the value of vd. vd is minus 30 sin of theta plus hd is 75 cos of theta. Once you get the value of theta, you can easily get the value of nt. So let us kept is unknown. Now radial shear. Radial shear means this force. So the forces in this direction is positive. So vd is the same direction. So I will write vd cos of theta, which is in the same direction, and upward minus this v hd sin theta. And we know that vd is your minus 30 cos of theta minus hd 75 sin of theta. Now to calculate a theta at any point, we have the formula slope at any point tan theta is equal to, I can write here, dy by dx is equal to 4h upon L square into L minus 2x. We know that h is the rise, L is the span, and x is the position at which we have to calculate theta. So we have to calculate theta at a distance 4 meter. So hence tan theta is equal to 4 into rise is your 4 meter, length is 20 meter, so 20 square into length 20 minus 2 into x is 4. So from this you will get it. To use a calculator. So 4 into 4 divided by 20 square into bracket 20 minus 2 into 4 bracket complete 0.48, tan inverse of 0.48, I am getting 25.64 degree. So I just put over here this value minus 30 sin of theta is 25.64 plus 75 cos of 25.64. I get the value. So here minus 30 sin of 25.64 plus 75 cos of 25.64. I am getting the answer 54.63 kilometer. Now I will go for the next here. Minus 30 cos of 25.64 theta minus 75 sin of 25.64, getting value minus 30 cos of 25.64 minus 75 sin of 25.64, and answer is, gives us the answer 59.57. So like this we will get the normal thrust and radial shear. So this is your numerical for 7 marks.